$26 has lots of parts. That's okay. Looks like on the left. I mean, it looks like a lot, right? But really, all we're doing is we're going to a specific location. This is saying what is it's doing like in the end. Okay, going to either positive or negative. So that's how that works. No big deal. Let me move that chord. Okay. All right. So absolute value function. This guy is a V shape. All right. This guy here is looks like this. Okay, he's kind of famous, right? Yeah, this is a favorite of mathematicians because it gets under the hood of how limits work. All right. So, anyways, as we go to 0 here, when we plug in the 0, we will get just 0. If we are going to negative infinity, if you know the graph. Okay, we know that this guy's just going to shoot off to positive infinity. The answer is positive infinity. All right, and you don't have to put the positive; you could just put infinity. But what if, like, you didn't know the graph, right? What you would do is you'd pick a very large negative number, right? And if you put a very large negative number, he would end up being positive by virtue of the absolute value. So he's just going to be a positive infinity. So remember, when you do shoot off to infinities, just remember, you could just pick an arbitrary large number that is either positive or negative. All right, so coming over here, though, if we're going to 0 here, we would basically say, like that, for B, that is a DNE, right? Because it's a general limit at 0. And so if we came from the left, no big deal. If we came from the right, no big deal. But if we're coming to the general limit, it does not exist. If we're going to -5, though, -5 would be over here. And so -5, you would end up with a +5 over -5. And there's our -1. So this guy would be a -1. All right, but what about this guy? What are we doing as we go to positive infinity? If we're going to an arbitrarily large positive number, that doesn't matter. It's already positive. So if you take the absolute value, he will stay positive. So he will be positive infinity. Okay, now this guy is just a constant. It's just 6. Okay, I don't know if this helps to have the graph. The graphs help me so much visualize what's going on. If I'm going to 2, it is 6. If I'm going to negative infinity, guess what? It's also 6. All right, cosine kind of wobbles, right? He goes like this. He starts at the top, and then he kind of just goes like this. That should dip lower to -1, but doesn't matter. As we go to 0, trigonometric sine and cosine are continuous. Tangent is not, but cosine and sine are continuous. So as we go to 0, you'll notice that it actually equals +1 from the right, +1 from the left. So that's 1. But as we go to positive infinity, here's the problem. The problem is that he keeps going from +1 to -1. He just wobbles back and forth, right? He doesn't fix himself to one location. Okay, there's no asymptotic behavior. It's periodic behavior. And so what happens is that this guy, he cannot pin down to a particular number. He just goes back and forth between -1 and +1. Okay, so it doesn't exist. Okay, all right. This guy looks like we have a. This guy doesn't exist either because this guy would look like this. Okay, okay, he's your typical rational function, DNE. Okay, now if we said coming from the left, he would be going to negative infinity. If he was, oh, here we go. If we're, oh, that's going the other way. My bad. If we were coming from the right, he would go to positive infinity. If we're coming from the left, it's negative infinity, but, you know, actually it shouldn't cross that. But either way, it doesn't exist, okay? Now, if we're going to positive infinity, you'll notice, though, that this guy does go to 0. This would be kind of a bottom-heavy situation, okay? That is a bottom-heavy, so this guy would be 0. And then also, if we're going to negative infinity, also the same thing, so he would be 0 as well. All right, so it looks like we're going to +1 here. Oh, that's easy, right? You just plug that in. So that'd be a 5 over -1. That's -5. Okay, if we're going to 2 here, though, nope. Looks like that's a general limit. And so the 2 does not the x minus 2 does not cancel out, so that guy would have to be an asymptote. So he doesn't exist, right? So we can't even say if it's a positive or negative. Excuse me, because one's going to go positive, one's going to go negative. It's going to be both. Now, if we are going towards positive infinity, though, okay, here's where end behavior comes in, okay? And this is what's nice. What do we know about an x over x? They're the same degree. So it's really just a 1 over 1, okay? So when we go off to infinity and negative infinity, we look to end behaviors and see top heavy, bottom heavy, same degree. Okay, we're looking for that kind of stuff when you see this stuff. Okay, don't try to mix the planes there. When we're going to particular numbers like 0 and stuff, that's different than the end behavior. So these guys are shooting off to 1 in both directions. All right, so now this guy, oh man, we've seen this guy before. We got x minus 2, and then we got an x minus or x plus 2, x minus 2 here. We know that those guys cancel out, so we get a 1 over that. Let's see what happens. What happens when we go to 0? All right, if we go to 0, it looks like we get 0. We get a positive 1/2, which is, yeah, positive 1/2. I plugged it into this one, got the same number, and plugged it into here and got the same number. I got a 1/2. Okay. Now, if I'm approaching negative 2, that would give me 0 here. Okay. Negative 2 does give me a 0. So in this case, what would have to happen, there's a D&E because that's an asymptote. Okay. Now, if I went to positive 2, that's just 1/4. Okay. Because I can just plug it into here. All right. Positive 2. Now, the reason I can do that is because, remember, 2 would have given me a 0 here, but that's a whole because they cancel out. So I can just go 1 over 2 plus 2 now. Okay. All right, so those are good. Let's go over here. Where is this guy going? It looks like this is bottom heavy. This is bottom heavy. So don't do any math. It's bottom heavy. If you're going to positive infinity, it's going to be 0. If it's going to go to negative infinity, it's going to be 0. Okay. So that's cool. Now this is top heavy though. I can see. Oh, but it looks like we got some things going on here. It looks like they switched it on us. Okay, what does that do for us? Let's see. These guys do cancel out. Okay, cool. So if we go to 2, though, it looks like if we are going to 2, then there's a hole. So if we took the limit, we can just plug it straight into there. That's 4. Plug it into 0. That's no big deal. Don't overthink that. That's just 2. Okay. What happens when we go to infinity? Okay. Well, it did cancel out, so let's think. If I have a very large positive number plus 2, it's still a very large positive number that is going to go to infinity. What if it's a very large negative number plus 2? It's going to be a very large negative number plus 2, okay? So that's it. We're looking at this, the 2... this guy would actually look like a line, and then at positive 2, he would just have a hole. That's what he would look like, okay? And so this guy would shoot off to negative infinity as we go to the left, positive infinity as we go to the right, okay? All right, how many? Okay, good deal. That is first study guide, and we'll get the second one going, part 2.